go back to more testing. What are we doing now, Joe?
All right, so we are taking the 3001 and putting it on the audio precision now. First test is going to be power versus THD. It, to me, is one of the most important tests because you're normally not listening to any amplifier, even a sub amp, at full volume all the time, right? So traditionally, companies like ours will rate their amplifiers at 1% THD. But most of the time you're listening to them, they're somewhere underneath there, right? So seeing the curve and seeing the floor that the noise sits on gives you a lot better idea of what you're going to hear when you're listening to it, especially on full range amplifiers. But in this case, we're looking at a pretty big monster mono, but same idea applies there if you're doing critical listening. So we have set up here is we've got input voltage at 100 hertz. We're going to run this test from basically 100 millivolts in all the way up to 6 volts in, and you're going to get a power sweep on the other page. So here we go.
And one of the nice things about the audio precision, you get the graphs versus just a static number. So this is going to be nice to show that power bandwidth.
Good.
When the audio precision works properly.
All right, here we go. So what you'll see is the graph coming across here. As we keep up an input voltage.
And what is that graph showing?
This is power versus THD. So the bottom lines here is your 200 watts, 300 watts, 5, 1K, 2K, 3K, 4K, 5K, 6K. The line going vertical here, that's your THD. So like we normally, like pretty much everybody, anybody that cares about their products will rate them at 1% THD normally. So 1% THD with this amplifier being hot is right about 3,457 watts, right? And that's how we get our 3,000 watt rating, is from something very similar to this. So we run the amplifier, we look at, but there's things we want to look at when we're designing the amplifiers, right? A good, nice, flat noise floor, as you see here with this line, is important. You'll notice the noise floor jumps here, right? That's when the amplifier switches modes from being synchronized to unsynchronized. You get a little bit of a spike, but you'll notice it's still down around 0.5% of THD. Yeah, this here is where you start hitting the limits of the power supply. So as you hit the wall and you start heading up, that is because your power supply is starting to make more and more noise as you pull from it. And then when you hit the wall, like if we went all the way up to 10-15% THD, you'd see this start to turn and go straight up. So at one point, you hit the power supply where it just can't go anymore, right? It'll go up. So at 1%, we're making 3,457 watts. But at 5%, right, you're making 3,890 watts. And so, like I said, when it's looking at uncertified power on the dyno, it's somewhere between like 4 and 8%, 4 and 10%, depending on the test. And so that's how you get those numbers, because it's running it harder into clipping, basically. So tons of power, very low noise floor. Anything under 0.1 is usually considered a really good design on the noise floor. These ones are 0.0 under 3 until they hit over 2,000 watts. Very quiet, very clean. Now we'll get on to Drew's question.
Yes.
Power bandwidth. Why is power bandwidth so hard on an amplifier? Well, one, because the CTA test that we helped develop actually requires you to do power bandwidth for 60 seconds, right? So here we have this pulled down on the amount of steps we do, but this is still probably 35 seconds here of power. So literally you're just cooking an amplifier into a fixed resistive load, which is about 45% more current draw than a speaker will be, right? So you're pulling more current through the output divisors, you're pulling more current through the power supply, the wire, everything's getting stressed. You won't be able to duplicate this in the field, and that's why a lot of people can get away with running our amplifiers and others at half the impedance they're rated at or less, because in the real world, the speaker doesn't draw as much current as a fixed load does. So these are extreme tests meant to make sure that the amplifier will pass, any real world thing you throw at it in most cases. But in this case, we'll let you see how this goes. I think I'm going to go out a little bit farther than 250, because when I did this earlier, you couldn't actually see a 3 dB down on the top. We'll see what happens here. This will also make it a little more brutal.
Yeah. We put our amps to the test here. And there she goes.
So the blue line is basically the power bandwidth, which I started a hair late, so you might have to redo this. The green line is your THD. And so the
So as the
THD is
power
over
goes
here
up,
on
the
the right.
THD is actually going down.
As the frequency goes up, yeah, because the smaller the frequency, the less difficult it is on the power supply to maintain voltage. And so you'll see that. You'll see as the higher frequencies happen, right, the THD goes way down. Let me run that one more time because we missed the beginning part. All right, let me turn this off now that we stopped. Keep cooking it. So this is why power bandwidth is so hard on an amplifier. So with all the steps that are in here, you just saw it takes 30, 45 seconds to even run a subwoofer amp here. So we have this reference to 3,000 watts, so that's the 0 dB mark here. So on the low side, right, we could go down lower and say this is like a 10 hertz amplifier to something if you really wanted. Come up here, so 0 dB is your mark, right, and this crossover is at the highest point right now. So negative 3 dB is going to be right about 140, 160 with the crossover. That's how it is right now. And that's how you get your power bandwidth. So in this case, right, you would change this from dB to power, which we can.
That's the nice thing about that AP is you've got so much adjustment that you can set up the screens for. And
So here, 3 kilowatts, right, all the way across, and then until you're down, but you can't do dB here, right? So you have to go to the dB screen to actually see where your 3 dB down point is, but you can see where I kept it here. So basically, all the way across this bandwidth, we make what they consider the similar amount of power for this. You can see it does start to go down with power just a hair at the low end because we do have a 10 hertz high pass on these for the subsonic, maybe 15 hertz, but it's outside of the audio band on purpose. But that's why it's so hard, because the time it takes, right? You're just literally cooking the amplifier.